Hello again, everyone. We're starting the second part of 8.1 exponential growth. Let's review quickly the main features of this function. This is the form of exponential growth. Y equals a times b to the power x. And a here, the factor multiplied by the base, is always the y-intercept. And we also call it the initial value or the starting amount, which corresponds with x is equal 0. B, the base in exponential growth, is always greater than 1. While the input here in this exponential function, in this particular function, the input is the exponent. The x values are the exponent of exponential function. Exponential growth. Now, as we are moving on in our objective to graph exponential growth functions, we're going to introduce a new kind of graphing when the graph is translating up or down. In this part of the video, we're going to explain how we can graph the exponential function after translation. What does it mean to translate a function, or what is translation? Translation is either to shift the graph vertically up and down or horizontally left and right. Let's first introduce the vertical translation. If you add a number to a function, like C here, this will cause a vertical translation up, while subtracting a number from the function will cause a vertical translation down. Let's see this over the graph here. If the original graph, the basic one, y equals 2 to the power x, is introduced here, is represented here by the blue dotted graph. This is the basic function which we already learned how to graph it in the previous video. Now, if you added a number outside the function here, like this 3, the new function became y equals 2 to the power x plus 3. Now, this 3 which is added to 2 to the power x will cause a vertical translation up 3 units. It means the whole graph, the whole blue dotted graph, is going to be translated up, is going to be shifted up 3 units. Let's see here. The original one has a y-intercept 0, 1, and this 0, 1 now, you can count 3 units up, 1, 2, 3, will be 0, 4. For subtraction from the function, if you subtracted 4 units from the function, it causes vertical translation down. So again, adding up, adding to the function from outside, causing vertical translation up, subtraction causing vertical translation down. I'm going to erase this to make it clearer for you. The y-intercept of the original was 0, 1, and now it is shifted down 4 units, 1, 2, 3, 4. This is the new y-intercept. Let's introduce the horizontal translation, y equals b to the power x plus c. In horizontal translation, I'm adding or subtracting to the x itself, to the values of x to the exponent. And as you will know now, adding to the exponent is causing horizontal translation to the left. So adding, the graph is going to be translated to the left, while subtracting a certain value from the x, from the exponent, is causing horizontal translation to the right. So again, subtraction causing horizontal translation to the right, adding causing horizontal translation to the left. Let's see this over the graph here. Y is equal 2 to the power x. This is the original graph. If I added 3 to the x, now the function became y equals 2 to the power x plus 3. I added 3 to the exponent. Now the graph is going to be shifted 3 units to the left. If this is the y-intercept of the original one, you count 1, 2, 3. This will be the new point of the new graph after translation 3 units to the right. And same here for the green one. I subtracted 4 from the x values from the exponent, and the function became y equals 2 to the power x minus 4. This will cause a horizontal translation to the right. If this is the y-intercept, count 1, 2, 3, 4. This will be the new point. And you can do this over all the points actually. You can just count 4 units to the right and you will get the new graph. Let's sum it up here. Horizontal and vertical translation is produced when you add or subtract a certain value like h here. This will cause a horizontal translation. It means the graph is going to move right and left. While adding outside, adding to the function like k here plus k, it will cause a vertical translation with k units. Okay, so adding to the x is causing a horizontal translation to the left. Subtracting from the x is causing horizontal translation to the right. Adding outside the function like here, like this value of k, is causing vertical translation. And if this k, when you add, it's up. When you subtract, it is down. Okay? Let's see if it's required from you to graph this example, y equals 2 to the power x minus 4. If you want to graph y equals 2 to the power x minus 4, you start by graphing the original basic function before subtracting the 4. As we have learned in the first part, we start by constructing table of values, assume some negative values for x, 0, and some positive values, and then you plot them and graph 2 to the power x, like this, and you will have this blue graph here. The y-intercept 0, 1, and we have 2 corresponds with 4. This is the graph of y equals 2 to the power x. Now you need to graph y equals 2 to the power x minus 4. So since we already know now, subtracting from x is causing shifting 4 units, shifting to the right, horizontal translation to the right. It means subtracting 4 from the x is causing horizontal translation 4 units to the right. So this 0, 1, when you count 1, 2, 3, 4, this is the new point 4, 1. You will get it and plot it. And then this 2, 4, again, you count 4 units to the right, 1, 2, 3, 4, you get the new point 6, 4. Now you have 2 new points. You just join them with a smooth curve over the x-axis, increasing from left to right, very close to the x-axis from the left, and increasing along the y-axis. So again, if giving y equals 2 to the power x minus 4, and you need to graph it, you start by graphing the original basic one using the table of values which you have studied in the first part, and then you see which kind of transformation you have, if it's added or subtraction. If it's addition or subtraction from the x values, from the exponent, you would know that the graph is going to be shifted horizontally, subtraction to the right, addition to the left. If it's required from you to graph y is equal 2 to the power x plus 3, again, you also start with y equals 2 to the power x. You start with the original basic one, which is here introduced or represented by the blue graph. Again, the y-intercept 0, 1, another point 2 corresponds with 4. And then you start to decide which kind of transformation or translation do you have here. The 3 is added outside the function. The 3 is added here to the whole function. It means it's a vertical translation. And as we said, when you add up, when you subtract down. So adding 3 to the function, it means this graph is going to be shifted 3 units up. So if this is the blue one, is the original basic one, each point is going to be shifted up 3 units. This y-intercept 0, 1, let's count now, 1, 2, 3. This is the new y-intercept 0, 4. And this point 2 and 4, when you add 3, when you count 3, 1, 2, 3, you will get a new point. Again, you will have 2 points. You can join them smoothly with a curve, since you already know the shape of the exponential function. But one more important point here about this graph with the vertical translation. The asymptote for all exponential function, as explained before, is the x-axis, which has an equation y is equal 0. In horizontal translation, the asymptote remain the same, and actually the domain and the range also stay the same. The domain for the new function here is also a real number. The range is y greater than 0. But in vertical translation, actually, the range changes, the asymptote itself changes. If the asymptote here y is equal 0, and now everything is shifted up 3 units, it means also the asymptote is going to be shifted up 3 units. This is the original asymptote of the original function. After translation, let me graph it with a different color here. I will count it. I will erase everything so it can be clear for you. Again, this is the asymptote y is equal 0. I will shift the asymptote 3 units up as I shifted all the points. 1, 2, 3. This will be my new asymptote. Y equals 3. And it means in this case, the range also changes. In case of vertical translation, the domain stays the same, which is all real numbers, while the range here changes. The whole graph, the red one, is above this line y is equal 3. So we say that the range y greater than 3. Sorry, the place is very tiny. Y is greater than 3. Let's see this in details in the next two examples. Y equals 2 to the power x plus 3, and y equals 2 to the power x minus 3. First of all, let's answer number A. You need to decide in the first place what kind of transformation happening here. Yes, we added to the x, so this is causing a horizontal translation to the left 3 units. So you have to decide first, it is horizontal translation to the left 3 units. You always start with what? You always start with the basic one, y equals 2 to the power x. You construct table of values. I think it's more than enough to use only 3 points in this case. I can use a negative 1. 2 to the power negative 1 is half. 0, which is always 1. 0 corresponds always with the y-intercept 1 in this case. 1, 2 to the power 1 is 2. We can also use 2 to the power 2 is 4. And now I'll do my sketch. I'll show you the correct graph, the accurate correct one. I'm just sketching this here over you to show you the steps of graphing. I will start graphing the original one with the blue color here. Again, negative 1 corresponds with half here. 0 with 1. 1 with 2, and 2 with 4. 1, 2, 3, 4. And you join them with a smooth curve very close to the x-axis, approaches toward the x-axis from the left and increasing to be closer to the y-axis from the right. This is the original basic function 2 to the power x. Now, I know that, as we decided earlier, adding 3 to the x is causing horizontal translation to the left 3 units. So each point is going to be translated 3 units. As you can see in your textbook and over the presentation, we only can, it's more than enough to only shift 2 points. I'm going to shift the y-intercept, which is very important point actually, 1, 2, 3. This will be the new point. And this point also 2 corresponds with 4. I'm going to shift it 1, 2, 3. And then I will sketch my graph. It's not accurate. Smoothly enough, approaches toward the x-axis from the left and approaches the y from the right, increasing from left to right. So this will be my new graph, which is 2 to the power x plus 3. Let's do the next one. Again, I'll do my sketch. Those are the axes. Of course, you have to use a square. It's very, very big. Of course, you have to use your notebook, your square paper, a pencil, and a ruler to make your graph more accurate. Again, the blue color is used for the original one with y-intercept 0, 1, negative 1 with half, 2 with 4, 1, 2, 3, 4. This is the original graph before any translation. Okay? Now we need to decide the transformation happening here, the translation happening here. Yes, 2 to the power x minus 3 from outside here, subtracting 3 from the whole function, is causing vertical translation down 3 units. As we said, when you add outside the function causing vertical translation up, when you subtract like this case, it causes a vertical translation down. Now I'm using another color to see how I'm going to shift all those points 3 units down. And as we said earlier, 2 points are more than enough. This is the y-intercept, a very important point you have to start with. Now shift it down 1, 2, 3, and this one 1, 2, 3. Again, the asymptote itself, it was originally y is equal 0, the x-axis. Now you shift this asymptote to this asymptote should be shifted 3 units down. If this is the original asymptote of the basic function before the translation, now you shifted 1, 2, 3, and you will get a new asymptote here, y is equal negative 3. This green line is my new asymptote. Why do I do this asymptote? To know my boundaries for graphing the new function. I will use the red one to join now the points with a smooth curve, and I know my asymptote, so I would know that the graph is falling above this line and approaches toward this line but never crosses it. So let me review the points again with you, the steps. You start by graphing the original one using table of values, the blue one here, 2 to the power x. Then you start shifting everything. You shift the asymptote 3 units down, the green one here, and you shift 2 points are enough. You shift the y-intercept. This is a very important point. You shift it 3 units down, and another point to guide you where to sketch the graph, where to join the graph. Another point here, like 2, 4, I shifted it 3 units down. Now I have 2 points. You can join them with the shape of exponential, and remember, it never crosses the asymptote here. It falls all above this asymptote. Now, let's see how to answer the second part of the question. State the domain and range. As explained earlier, in the horizontal translation, right and left, the domain and range stay the same. The domain of the first one here, the domain of all exponential function actually, is always all real number. The range here, y greater than 0. Horizontal translation does not affect the range. Again, in the second one, the vertical translation, the domain, as stated earlier, is always all real numbers for all exponential function. Now, the range, the y values, as stated before, since the whole graph shifted down 3 units, the asymptote shifted, and now the graph is above y equals negative 3, so the range is y greater than negative 3. Okay, those are the accurate graphs here. The blue one, using a square paper, of course, like yours. The blue one is the original. Those are the 2 points I plotted, and those are the 2 points I shifted to the left 3 units in the first graph. Again, the domain here is all real numbers. The range is y greater than 0. For the next one, B, okay, I shifted the whole graph. It was y equals 2 to the power x minus how many points is it? 3 also, negative 3. I shifted everything 3 units down. If you counted here, if this is the original one, the blue one, 1, 2, 3, and this one also 1, 2, 3, and I got new points. And as I said earlier, you also can sketch the asymptote. It was the x-axis here, shifted down 3 units, so the new asymptote is y equals negative 3, and now the domain stays the same, all real numbers for all exponential growth function, and the range is y greater than negative 3, because the whole graph is above this line, the new asymptote. Now this is your turn. Pause the video, try to graph this given function, y equals 3 to the power x plus 2. Let me help you by giving you some hints. the steps you're going to use, you're going to graph first y is equal 3 to the power x, use a table of values, plot the points, and then you know that adding 2 to the function causing vertical translation 2 units up. Again, the steps, you're going to start by sketching y equals 3 to the power x using table of values. Assume negative values and positive values for x, and find the corresponding values of y, and then decide the kind of translation here exactly. Since we added 2 to the function from outside, it causes vertical translation 2 units up. Let's see the accurate graph now. This is the graph. And as we said, in vertical translation, it's better for you to show the new asymptote. Let me, this was the asymptote of the original function, y is equal 3. I shifted everything 2 units up, so the asymptote itself shifted up 2 units. It became y equals 2. And then those several points, you join them smoothly with the shape of the exponential function. The domain, as stated many times, all real numbers. The range here, you can see the graph is all falling above this line, so the range y greater than 2. Again, pause the video and try to answer this one following the same steps we said earlier. You graph y, you start by graphing the basic function, y equals 2 to the power x. You decide about the translation, yes, sure. Adding 2 to the x causing horizontal translation to the left. And then you shift all the points to the left, 2 units. Here is the new graph. As stated earlier, the domain all real numbers, and the range is not affected by the horizontal translation. Again, I'm repeating again, only vertical translation is affecting the range. The domain in both cases, in both translation, the domain stays the same, all real numbers. As you can see, the graph is always spreading above the x-axis from positive side and negative side. It covers all the x values over the x-axis, so the domain always all real numbers. Only for the range, it's affected in vertical translation. The range in horizontal translation stays the same, y greater than 0. Only in vertical translation, it is affected by shifting up and down. Okay, till we meet again, I want you to check all your homework uploaded on the drive, and inshallah, we meet again in our next Zoom meeting.